The same two curves, but one time we just rotated them around axis, and then the second time we rotated them around a horizontal line, y equals 2. So we're going to do one more. We're going to do the same two curves again, but this time I'm rotating them around the line x equals -1. X equals, bless you, what kind of line is that? Vertical. Y equals is horizontal, x equals is vertical. So we have to start with a picture. Okay, if you look back in example A, my curves were y equals x and y equals x squared. And we've already drawn those a few times. We know y equals x is just a line, y equals x squared is a parabola, and we found that they intersected at 1. We had the parabola on top, or the line on top, and the parabola was underneath. So that was the little picture that we got in part A yesterday, and we also used it in example B. So now x equals -1. So vertical line at -1. If I'm going to rotate this around that line, we have to first think of it as reflecting. So this point is one away from the line, so it goes one away the other direction. Then we had a line on top, a little parabola underneath. And so our picture looks kind of like this. We're getting a bowl here, flat bottom. So remember, when we rotated this around the axis, it kind of looked like a funnel. It went to a V. By rotating it around that other line, we turned it into just like a bowl with a flat bottom on it. Can you guys kind of visualize? I am not artistic, so I know my pictures are a struggle sometimes, but hopefully you can. Well, thanks. Okay, so if I am going to set this up, do we have a definite top and bottom or a definite left and right? Top and bottom, right? Because if you think about the left and the right, it depends on where you're at. But no matter where I'm at here, we have a top and a bottom. So those are my y values. So we're going to go from 0 to 1. And 0 and 1 are y, so we need to do it in terms of y, so dy. So because it's hollow in the middle, this is a washer method. So we have to do the first one squared minus the second one squared. Okay, when we do it in terms of y, you want to think outside minus inside. So outside. It's like saying if I'm starting here and I go all the way out, which one is on the very outside? The y equals x squared. Now, I don't want x squared here. I want y's here. So what would we have to do? Square root it. With that, we typically do a plus and a minus, but if you're talking about a radius is a positive number. Right? So we're just going to keep it as the square root of y. However, that's not really accurate because I'm not going from 0. So my radius is all the way over here. From here to here is the square root of y. What would we have to do to take into account this? Plus 1, because it's 1 more than that. So it's the square root of y plus 1 for my radius. And again, the reason that we can't just use the curve is because I didn't rotate around the axis. It's a different line. So we have to think from all the way over here at -1, how far do we have to go to get to the edge? All right, then we have to do the inside. So starting here to get out here. So this is the curve y equals x. So we're going to use the y. But what would I have to do with that?
X plus 1.
Yeah.
Or what?
Y plus 1. All right. Have I lost anybody? So now we can clean this up and start integrating. So I'll take out my pi. To square this, you have to think about writing it twice and FOILing. So square root of y times the square root of y would be y. Plus the square root of y plus the square root of y is 2 square root of y plus 1. Minus, this would be y squared plus 2y plus 1. So, combining like terms, if we distribute this negative, we will have a negative y squared. Positive y minus 2y is negative y. Positive 1 and negative 1 drop, and then the 2 radical of y, I'm going to write it as 2y to the 1/2. So now we do the antiderivative. So antiderivative of negative y squared would be negative 1/3 y cubed. Antiderivative of y, negative 1/2 y squared. Okay, y to the 1/2, if you add 1 to the power 3/2, so we need a 2/3 in front, times my 2 is 4/3. We put in a 1. 1 to n power is still 1. Put in a 0, that's just everything turns into 0. Negative 1/3 plus 4/3 would be 3/3 or 1 minus 1/2. So we get pi times a half or pi over 2. That is very important. Alright, let f of x equal 5x and g of x equals x squared. And let R be the region between the graphs of f and g on the interval 0 to 3. Let's stop right there and kind of draw this. So 0 to 3, those are my x values. Alright, if I plug in 0, I'm going to get 0. This is going to get kind of large. Okay, so f of x equals 5x. So 5 times 0 is 0, 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15. So we're just getting a line for that part. G of x equals x squared. So 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. So do these curves even actually meet at that ending point? No, but I told you we are only going from 0 to 3, so we know we're stopping there. Okay, now what I want to do is take this and reflect it over or rotate it around the x-axis. Your graph, doesn't have to be perfect here. But, so the line, if I just reflected it, would come down like this. Crackle looking thing. So what we're doing is rotating this. And we're looking at this one. do we have a definite top and bottom or a definite left and right here? Left and right. So we're going to start when x is 0 and end when x is 3. It's hollow in the middle, so we have to do the washer method. So these are all circular. So the first squared minus the second squared, and we are in terms of x. So the first, the outside, that's like the top here, which was my 5x. The inside, that's my green one, which was my parabola, the x squared. So we get 25x squared minus x to the 4th. We do the antiderivative of 25x squared. 25 thirds x cubed. Antiderivative of x to the 4th will be 1/5 x to the 5th. Put in a 3. 3 to the 3rd, we could cancel one of those 3's. So then we have 3 squared, which is 9. 9 times 25. 25. Think about 9 quarters. How much money do you have? 3 to the 5th. 243 over 5. You might put in 0, you just get 0. Eight 82 pi over 5. You guys trust my math, don't you? The section. So suppose a pyramid is 4 units tall, has a square base, 3 units on the side. Find the volume of the pyramid. All right, we have a formula for volume of a pyramid, but let's try to work it out without that. So, okay, I'm going to draw a pyramid. So here's my pyramid. It's 3 units on a side. So this is 3, and this is 3 because it was a square base. Let's draw. So if I place this on an axis, it's going to be kind of hard to visualize, but let's say we have the y-axis just coming through the peak. So that's my y-axis, and it's sitting on the x. Okay, so the height of this thing is 4. I know that's a horrible picture, but bear with me. We can't set this up the same because when we look at a cross section, what shape will each cross section be? A square. When I talk about a cross section, we're talking about if I just cut a slab right here, and you would be looking at a square for every cross section. Okay, so if we're going to find the volume, we would have to integrate. This, we have a definite lower and higher point, right? If we set this on our axis, it starts at 0 and it would go up to 4. But then we need something for area of a square. Area of a square is just length times width, right? And we know since it's a square, those sides are the same. We need it in terms of y because the 0 and the 4 are y values. So we need some kind of equation to give us the length of this side. So let's talk about one face of this pyramid. I took one of these triangles. Okay, I know the length of that is 3 and the height is 4. And my cross section comes in right here. We don't know what this length is. Let's call it x for a moment. But the amount you came up, that's your y value, right? Because this is our y-axis. So the distance from the top would have to be the total distance minus the amount you rose. So what we can actually do is use similar triangles to find that x. We can do a proportion. So it would be like x over 3 equals 4 minus y over 4. You multiply your 3. And if you broke it up, you get 3 minus 3/4 y. So that is the length of one side. So then, if I want to integrate this, it'd probably be easiest just to go ahead and FOIL that out first. So that could give me a 9 minus, it'd be 9/4 times 2, so 9 has y plus 9 over 16 y squared. So then if we integrate, and so if we plug this in, we get 36. 9/4 times 4 squared, so all the 4's could cancel, so 9 times 4 is 36. 4 cubed divided by 16 is 4, times 3 is 12. And the formula for area of this is 1/3 area of the base times the height. Area of the base is 9. 1/3 times 9, the height was 4, is 12. So that's where the formula comes from. But I just wanted to show you one example to show you that it doesn't have to be circular. That's just what's happening when we are rotating our curves around an axis. So I am done for today. I have 3